Hey everybody, this is Larry. This is day 18 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem and so forth. So I'm not gonna lie, I've been producing some alcohol. So I'm a little bit slow today, but that's okay. Hopefully, we'll see how that goes. I am subbing these live, so if it does happen to be a little bit slow, well, that's my reason and that's my excuse. Today's problem is find all numbers disappeared in an array. What does that mean? Okay, let's get to it. It is easy, so I have easier expectations, but let's go get to it. The number of nums where ends by return number that do not appear to it. Okay. So, that's a little bit awkward maybe, but I mean, so the basic thing to do if you're given linear space is going to be just put it in a hash table, a lookup table, and then just run through it. That'll be all event time, all event space. That's great enough. Of course, taking a look at the follow up, can you do about extra space? And can you do about extra space, right? Well, I mean, the short answer there is to kind of do a sorting and then just make sure that every array element isn't in the thing, and you can do a sort of a permutation sort or whatever it's called, where basically because from 1 to n, every x is going to be in the x index unless they are unless they do not appear, which means that some other numbers are duplicate entry, right? For example, here you if you sort it, 2 would appear twice, which means that 2 appears somewhere else, and then you can return that in an array. So those are things that you can do. It's pretty, I wouldn't say it's easy because it does require knowledge of the permutation cycle, and technically I feel like enough people have done it enough times that it is well known, but that does not make it easy because there's a lot of mathematical things behind it, and I feel like a lot of people just kind of know the quote unquote know the trick, but might not know the nuances of permutation cycles and so forth. But that said, that is enough. And basically the idea behind here is that, okay, so let's say you have this array. You can go from left to right, and then 4, you switch to 4 with the 7, so that because it goes from 1 to n. So then here, let's say you just begin with this, and then after one kind of swap, even though the point is still at 4, you would have here, because 4 is at 4, and then you swap to 7. So here, let's just make a fake pointer. So you're still at 7, and then you swap until, 1, 2, 3, 4, 5, 6, 7. So 7's here and 3 is here. And the thing is that you keep on swapping until one of two things happen. One is that this becomes a 1, which means they're done. Or in this case, let's say 3 is already here, or I guess here because this is one index. So if 3 is already here, then you cannot move, and that means that in theory, at least for now, the 1's not in a good place. Yeah, or this is, I mean, in this case, actually, there's a 1 later on, so we would have to go through the entire loop to make sure that's the case. But that said, eventually the 3 will end up somewhere, so maybe even here, and 1 will be here, and then you'll see that, you'll see things that are placed. So let's play around with that. Like I said, I'm not at 100% right now, so we'll see how that goes in terms of implementation, though I'm pretty relatively sure, even in my impaired state, that the algo is correct. Yeah, okay. Yeah, am I happy? I'm okay happy. So yeah, let's go. N is equal, oops. Oh my. I'm a little bit, let's just say my response time is not very good right now, but so let's just say for I to n, and then while I is not equal to num sub I, and well, this is true, because if that's true, then we could get out anyway. We do something like num sub I, what do we swap with? We swap with I, right? So let me think about this for a second. So one thing to do is just look at the examples and then kind of go through it. And in this case, you have, let's say you have 4. So let's say I is pointing at 4. So what do? Well, we want to swap num sub I is equal. Okay, so num sub I, something like this is equal to num. We have to do a few more things. Oh no, okay, so it's within 1 and n, so that's okay. So like this, except for we have to take a counter off by 1 because we're using 1 index instead of 0 index. So maybe just to make it easier for me to, because you can do this in place here as well, but just to make it a little bit easier for me, I am going to do something like this, just to make it a little bit easier, especially since I cannot think right now. So you do something like this, and then the only other scenario is if num sub I is equal to num sub, because that means that nothing gets swapped, right? So then here we break as well. So then you can actually put this here. And I think that, okay. So I don't know if this is right, but let's at least print out those current scenarios to see what the current situation is. Wow, my typing is really bad. I had maybe a little bit too much to drink. This may be, this is an infinite loop. Why would this be an infinite loop? Because eventually that should be good. That's weird actually. I would not expect this to have an infinite loop, but let's see what is causing it. Man, I had too much. But it's okay. This is for fun. I'm having fun. Are you having fun? I hope you're having fun. If you're having fun, then this makes these things a lot easier. If not, it is a little bit trickier, but sometimes you have to do things in life that you don't really necessarily enjoy. So I don't know. It is what it is. Okay. I mean, we know that there's going to be time limits. So, okay. How does this work? So I is 3 and 6. Did I mess up? I think I messed up somewhere. Because then it says 6 and 3. I messed up somewhere for sure. Because basically we keep on swapping 3 and 6, the index, but what we want is the 0th. So what we want is actually I. We don't want to switch I. What we want to do is we want to switch num sub I with the number that's at num sub. Okay, sorry, I'm a little bit slow right now, but basically we have this number and we have this number, and basically, but that's not what we want to do, right? We want to swap this number and 7. So basically, we want to. Okay, let's step this back a little bit. What we want is, because I try to go a little bit too fast. What we want is we want num sub I is equal to this thing, which is num sub I, right? So that part is right. Did I mess it up? I'm not going to. But then we want num sub I. So we. Okay, so I think maybe we are doing it right. Maybe I'm a little bit confused. So we swapped the 3 and the 6, right? And then what happens? So then that means that 4 is in the right place, but then 6 is not. But why is 6 3? Maybe I did do something wrong. 0, 1, 2, 3, 4, 5, 6. Well, that's 3, but it should give it 2, right? Okay, let's print out the numbers. Sorry, friends, I'm not 100% today. I mean, the idea is, I think, is right, but we're clearly doing something a little bit off. Um, So I guess we'll see. Okay, so you start off here. Yep, that's right. We subtract 1 from everything. And then we subtract it. We mixed up. Okay. Num sub I is going to be 3. And then num sub I is 6. Okay. But we swap, and the swap is not correct. Because this should be 3. Right? All right, let me brief out a little bit. So 0, 3, and 6. Okay, so this is 3, this is 6. So what we want is, I don't want to change I, but what we want is, now I is 0, right? So we want this 3 to be a 6, and that's fine. But we want the 6 to be a 3. Did I mess up somewhere? Why is this a 6? I think that's the issue, is that we have 2 6s, and that's clearly wrong. Do I have a typo? So this is equal to 6, which is fine. And then here is wrong. Is it? Maybe this is a little bit weird. Maybe I didn't think about it in terms of this, but okay, let's just say we have, maybe I'm learning something that I did not know before. Do I need to do this? Let's see. Huh. I didn't know that you need to do that. Why is that? I guess there's some like, I always assumed that this was in one operation. That's why I wrote it the way I did. But I guess today, even maybe a little bit impaired, I figure out the way that I did. So yeah, so you have this thing, which is actually, oh no, that's the output. So we have this thing where now we have what we want, right? Which is the fact that, let's see. Okay, so I think we're in a good place again. Today I learned that there is some weirdness with respect. Like I thought this was atomic, but apparently it was not, right? So then, yeah, you have answers, you go to and then for I in range of n, if num sub I is not equal to I, n start append I plus 1, just because we have to make sure we have to add that in, and then return answer, right? Is that right? That should be mostly right. And this is very standard-ish in terms of this kind of thing called permutation cycle. Okay, so I was right mostly. It's just that I didn't know about this. So it's kind of just to be a little bit transparent, is that I was doing something like this, and it turns out that that's not good enough because there's some like intermediate levelness that I don't really know about. Okay. So this was wrong and this is right, and I really had the idea correct, though my implementation's a little bit off. Yeah, I mean, I think we're mostly good here. Let me just put in some more test cases and see if they run. Okay, so this looks good. Let's give it a submit because I am at a low whatever level right now, carrying level. Okay, so that looks good. Yay, 597. And also, this is the first time, excuse me. This is the first time I've solved this, which is, I don't know, I don't remember this per se, but I do remember the trick about, the quote-unquote trick about permutation cycle. If you want to do a read up, do look up permutation cycles. I don't know how much it helps, but that's the idea, is that, okay. Because in this case, the thing that we do end up is that each number will only move once on average, because either it moves, because every time you do a swap, one number is closer to the So basically, yeah, let's say you're given this input, and your quote unquote expected input is just like a sort of increasing thing. And every time you do a swap, one number is closer to it. So in total, it's going to be O of n, because at worst, it's going to make n changes, n swaps, right? So that's basically the idea. And after the swap, the only numbers that are not in the right place is going to be the numbers that appear in duplicate times. And also it means that the original number did not exist. So that's why I do it this way. This is going to be linear time, constant space, which is kind of what we did in the follow-up. Otherwise, I wouldn't do it this way. Otherwise, you could put it in a hash table and everything is okay. But yeah, do I have anything else to say? Yeah, apparently don't do this. This changes and therefore something weird happens. I did not know that, and I ended up debugging for a little bit long. But yeah, that's all I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see you later and take care. Bye bye.